Hydrogen. Hydrogen is the smallest, lightest, and the most abundant element in the universe. And when talking about all the elements in the universe, the first element on that scale is what? Hydrogen. And as you can see, hydrogen is having an atomic number of 1. And most of the time, if you want to write the orbital configuration, we write hydrogen as 1s1. We'll be talking about some hydrogen fun facts. And the first thing is that hydrogen is the most abundant element in the universe. When looking at all the elements in the universe, you see that hydrogen contributes to the largest proportion of elements. You see that in water, hydrogen is 2 to uh, to 1 oxygen. And talking about the 70% of water, we can see that from that. Even the constituent of most organic compound, you see hydrogen there. For example, you see methane gas, you see 1 carbon bonded to 4 hydrogens. The other one is that hydrogen is a renewable, efficient, and clean source of energy because it burns quickly, so it gives a lot of energy. In fact, hydrogen is used in fuel cell technology. Another thing is that scientists have been producing hydrogen for years before they realized that it was an element. The next one is that hydrogen composed of a single proton and a single electron. Because the electronic configuration of hydrogen is still 1, so it consists of only a single proton and a single electron. The next one is that hydrogen is estimated to be 90% of the visible universe. That's why we say it's the most abundant element in the universe. Also, hydrogen is the raw fuel that most stars burn to produce energy. It is worthy of note to tell you now that the sun is a star. So, hydrogen is a major fuel that we find in the stars that makes them to keep burning and keep shining like that. And that same hydrogen is what we see in the world in the sun. So, and lastly, the sun supply of hydrogen is expected to last the next 5 billion years. It has been estimated that the fuel, that is hydrogen in the sun, is going to burn for roughly 10 billion years. And out of that 10 billion years, the sun has already lived like 4 point something billion years, approximately 5 billion years. So it remains like 5 billion years for the hydrogen to finish burning in the sun. And after the hydrogen finish burning and the energy being supplied to the sun is removed, that means the sun will go supernova like other stars. Let's talk about isotopes. Isotopes are atoms of an element that are made up of same number of protons and electrons, but different number of neutrons. They undergo the same reaction, but due to their different masses, can behave differently in physical processes. So you can see that isotopes have the same atomic number, or you can say they have the same proton number and electron number, but the only thing that is different is their neutron number. So the neutron number is responsible for that phenomenon called isotopy. Hydrogen has 3 isotopes. The first one is called the common hydrogen or the protium. That's the 1 hydrogen as you can see there. And the second isotope is called the heavy hydrogen or the deuterium. That's the 2 hydrogen there. And we can see that the neutron there is going to be 1 because that's 2 minus 1. So it's having 1 neutron, 1 proton, and 1 electron. Compared to that protium that is having only 1 proton, 1 electron, and no neutron. Because no neutron for protium because the mass number 1 minus 1 minus the atomic number that's 0. While for the tritium is also that's a 3 hydrogen and is having 2 neutron, 1 proton, and 1 electron. That's a 3 minus 1. That will give us what 2. That's a 2 neutron. And we should know that the proton and the deuterium are similar in chemical behavior. They form water and deuterium oxide respectively. While for the tritium is an unstable isotope of hydrogen. At this juncture, it is worthy of note to tell us that we have 2 types of isotopes, which are the stable isotopes and the unstable isotopes. The stable isotopes are those isotopes that are happy to live together, they prefer to stay together, while the unstable isotopes, They are the radioactive one, the ones that are unable to live together. That is, isotopes are unstable because they cannot hold together. They have too many or too few neutrons compared to the normal neutron, and they are called radioisotopes. Most of the time, large atomic nuclei with more than 93 protons or neutrons are usually unstable. Like uranium is an example of such elements. But in this case of isotopy now, protium and deuterium are stable, while tritium is unstable. That we can say tritium is radioactive. So tritium is unstable and radioactive because it has too many neutrons compared to the normal neutrons that proton and deuterium have. Metals above hydrogen reactivity series liberate hydrogen gas when they react with acid. In the laboratory preparation of hydrogen gas, most of the time, zinc or any metal above hydrogen hydroxide series is always added to acid to give salt and hydrogen gas. Most of the time, provided the zinc marble is inside the container there, we can pour H2SO4 as an acid to the tissue funnel. And as we pour the H2SO4 in the tissue funnel, hydrogen gas is being produced. It moves through the delivery tube, and then the hydrogen gas is collected over water. Because hydrogen is insoluble in water, so most of the time we collect over what? Water. So more of that hydrogen gas will be produced and it will always be collected over water. We can test for hydrogen gas by what? By introducing a lightest splint. It gives a pop sound. It is that pop sound that tells us that hydrogen gas is present. So what are the precautions that we must take? Concentrated H2SO4 is not used because it acts as an acid and as well as an oxidizing agent, and consequently get reduced during the process to liberate SO2 gas. Also, pure zinc is not used in the preparation of hydrogen gas because it is non-porous in nature, and therefore the reaction between zinc and H2SO4 is slow.